Lavanya, just a question out of Kubernetes. So, conferences. I mean, like, I am just excited to know what actually happens in the KubeCon conferences.
Okay. Have you attended any of the, not only the KubeCon, any local meetups?
No, actually. Yesterday, sorry, last year it happened in Hyderabad, right? I didn't get a chance to attend.
So, KubeCon is a flagship event conducted by the CNCF community. So basically, if you go to a KubeCon, you will see a lot of people working on the same stream. So at least last year, there has been 5,000 people attending Hyderabad KubeCon. So you will expand your network. So it is best to, if you're going to work in Kubernetes, you must try to attend the KubeCon events, not at least the KubeCon. So there are other local events like KCD events are there. So other community days events are there. So those events you can try to attend, possibly at least yearly once you have to attend.
Okay.
You're based out of which place?
Hyderabad.
Okay, I think then there might be a lot of events happening in Hyderabad.
Okay.
So just to follow in LinkedIn, there are a lot of pages. You might be already following those pages. So all the event, they will send out a notice prior so that you can buy tickets. So currently, I think Mumbai KubeCon is on Jan 18, I guess. Sorry, June 18, I guess. So,
okay, this year, right?
This year. So just if possible, buy the ticket, and then I think if you're a company or arranges for a travel, then well and good. If not, I think you'll have to manage all the travel expenses and the entry ticket for it. So it is good to attend. So you will see a lot of people, and then you will expand your network. So basically, it's all based on the networking only. So nowadays, all job references, everything. So you have to have a good network.
Thank you.
Recording started, Shubham. Can we start?
Yes, ma'am. Yeah, please start. Yeah.
Okay. So, just a quick recap on yesterday's session for those who have not attended. So I would recommend all of them to go through the yesterday session notes and then try to do the lab as well. Okay. Yeah. So yesterday, what we have seen what is load balancer. So what is the use of load balancer and why we should not use load balancer for exposing the application outside. So we have seen that the drawback of it, and then how it was fixed. So we went for a Ingress controller called Nginx to have only one load balancer and to do all the path-based routing, host-based routing, terminations. Though we haven't seen a lab in SSL termination, but that is possible. So SSL termination is possible, and then you can send traffic to any path that you are configuring. So it is L7 based routing. So we have seen the Nginx Ingress controller there. And then we also saw how to achieve this in our lab using MetalLB. So MetalLB is a tool to assign IP address for load balancer. So since we are using kind cluster, we don't have any mechanism to assign public IP address. So whenever you create any load balancer, that will go in a pending state if you don't have any mechanism. So, but in cloud environment, Azure, if you in AKS, if you create any load balancer, it will create a public IP in Azure, and then it will use that public IP for your load balancer. But same for EKS as well. So still EKS will use a public IP behind the scene, and then you don't need to worry about MetalLB at all. So it's mainly for self-managed clusters and for our kind cluster. So that's the use of MetalLB. So from the name itself, you can remember that it's going to create load balancer. It is going to assign the load balancer, and we had two major components in terms of MetalLB architecture. One is controller and speaker. Controller is the one that checks what is the IP pool that you have assigned, and from that IP pool, it will assign the IP address for your load balancer. So that's the job of controller, which is nothing but IP allocator. Speaker is nothing but IP announcer. For example, if I create a load balancer now, it has assigned one IP. So it will announce that this IP is already allocated. So then the next time, if there is a load balancer creation, that time this IP will not be allocated. So the next set of IPs will be taken into account. Okay. So that's the use of load balancer. And then we have seen how the traffic flow works from external world until to the pod, how it reaches. So we have seen that flow. So basically from internet, you'll have to have a external load balancer, and then it will be mapped to your ingress controller. And then ingress controller is doing all the routing for your application. For example, it takes care of host-based routing and path-based routing. So host-based routing means different URLs. So app.matrixcube.com, app. So any volvo.com or app.bmw.com. So such apps. So it is called as host-based routing. For different host, you will configure different routing. So that's host-based routing. What's path-based routing? For a single host, you can assign different paths, /API, /web, /backend, /swagger, /image, video. All these are path-based routing. So based on the traffic that is being hit onto your application, that specific service will be called. So that is what your ingress controller will do. Basically, it checks the ingress resource for that service. And then if there is a backend service that's configured, then it will check for that service, and then traffic will be routed to the pod. And also we have seen the algorithm, which is round robin or content hashing or least correction. So there are different types of algorithm that's used. So by default, it's round robin. So different pods will be addressing the traffic. So each and every time you won't see the traffic addressed by same pod. It will be in round robin fashion. That's the load balancing algorithm. Okay, so we have seen that. And then so there are other alternatives for Nginx, I said. So we have seen Cilium. So better you can do a lab assignment with respect to Cilium ingress controller. And also Kong is one of the famous load Nginx ingress controller that also you can explore. And another one is Envoy gateway. So try to do a lab in any of these tools and see how these ingress works there. So just have a visualization, but the concept on all these tools remains the same.
Are you presenting the slides? I still see GitHub desktop. So.
Okay. Okay. Maybe share. Yeah. So I mostly I share my slide or my terminal. So if you're not seeing my screen at all, just let me know. Okay. Yeah. So we have seen ingress demo, how to deploy an ingress controller, and then we so what's the use of it? Now we are going to dig deep into the next level, which is what is the disadvantage of using ingress controller, and then how it can be solved using some other tools. Okay. Yeah. Any questions so far? No worries. Then I think we can start for the day. So in microservice architecture, how many services for a small application? You would have lot of services, right? Services means one microservice, which means your one single application can have hundreds of microservices, right? So it can have a lot of microservices. So do we have any mechanism to safely to have a safe communication between services? Do we have anything at the moment? Any idea? Did we talk about it?
By default, no.
No, right? So we are going to address that with a tool. Again, I said Kubernetes is not a simple tool. It has lot of other Kubernetes ecosystem surrounding tools, open source tools, addressing each and every problem that Kubernetes introduces. So you cannot just like that learn Kubernetes and without learning these tools. Okay, so that's the complexity of managing a Kubernetes service. So if your application is very small, it does not need a lot of services, then you don't need to go for a Kubernetes at all. Because if you go for Kubernetes, then you'll have to have controllers, Ingress controllers, and then you should have some scaling tools like CADA, and then for node management, Carpenter, and then you will have to have Ingress controllers, at least 1 or 2 Ingress controllers like Istio and stuff. And mainly, you should have observability tools. So Prometheus, Grafana stack, and then for logging, you'll have to have BLK stack. So all these tools, you need to manage it. And if you are going for GitOps model, again, one more tool should be added. For a small application, I would say that not to use Kubernetes at all. So better to go for any app services itself to solve the purpose. So the complexity would be to manage all these tools, and you have to do upgrades and manage these tools. So that is going to be a cumbersome task. So just so this will be evaluated when companies do migrate to Kubernetes environment. So it's based on their need, it will be done. So by default, not everyone needs Kubernetes services. Okay. Yep. So in cluster, we have hundreds of microservices, right? So these services, they do not have a secure means of communication. So they can talk directly without any restrictions at the moment. Okay. Unless you add any network policy, pod-to-pod communication will be broken. But there is no mechanism to restrict the service-to-service communication. So these services will not have any security to reach other services. And also, I have these dependencies. So my service 1 calls service 2. And this service calls service 3. And this service calls service 4. So my application has such requirement. Then if this service is having high load, okay, so this service is having high load, then what will happen? The dependent services will also be affected. So this service will also have a cascading effect. Okay, so this service may go down. And then eventually this service can also go down because of it. This service is not reaching or responding. So if one service is having a problem, then there will be a cascading effect. So for this, what we need to do, if this service is down, we should make this service down. So we should not have a cascading effect onto these services, right? So we should leave the service as it is. So for this, there is no mechanism at the moment to have a solution for that. So this is addressed by a tool called Service Mesh. So basically, Service Mesh is a concept of discovering the services. Okay, so that's called service mesh. In modern microservice systems, the services talk to each other constantly, right? And managing these communication becomes complex when you add security, retrace, monitoring, traffic routing. Everything will be complex when you add a lot of services to it. So how Istio solves this problem? It introduces a service mesh layer. Okay. So I will tell you what is more on the service mesh, and then we'll discover what are the features that these service mesh offer. So why we are choosing service mesh over normal Nginx Ingress controllers. So there should be an advantage of it, and also complexity of managing Istio is one thing. So 2 things we'll have to keep in mind, whether you need Istio definitely for your application, or you can just go with the basic Ingress controller. So that decision you'll have to make before using the service mesh feature. Okay, service mesh is provided by different tools like Istio. My screen is visible, right? Hello?
Yes,
Yeah.
it is.
Yeah. So what is the problem with Ingress controller? Let's see. So it does, Ingress controller does the TLS termination, but does it do encryption? It cannot do by default. It does not do the TLS encryption. And also, as I said, if there are problem with one single services, it will have a cascading effect, right? To stop this cascading effect, there are a lot of features provided by service mesh, which is it has a retry logic. If there is a failure, it will do n number of times, that how many number of times you are specifying in your application configuration, that many times it will retry and then it will fail. So that means this service will be failing. This one. So this one will be in failed state. Okay. So which means that there will not be cascading effect onto other services. So that type of circuit breaking, you can do it at the application level. Okay. And of course, you can do load balancing. Yeah, just a moment, I'll finish it up. So you can do load balancing across different services. So as I said, by default, it's a round robin, right? So the Ingress controllers that we spoke about yesterday, it does not provide advanced algorithms like so if a request is coming from one location or one client is sending a request, so always that request has to be addressed by the pod which has served last time. So which means that if they are connecting from nearby region, so it has to send to the same pod. So that is what the intention is. So there are different algorithms to solve it. So those advanced algorithm is provided by Istio. So that's what the advantage of using load balancing with Istio, because load balancing is offered by other Nginx controllers as well, right? So that should be an advantage of using Istio Ingress controller. Okay, so the Istio will again fall as in Ingress controller category only. Additionally, it is called as service mesh. Okay, why? Because these service discoveries are happened, and then there are a lot of other functionalities like it can do TLS encryption and retry logic. It does the load balancing, and then traffic will be managed. So there are different types of traffics that you can send. For example, if you have two different applications like canary deployments or canary deployment means at a time you can send traffic to two different applications. So 90% of the traffic will be sent to your production application, production version, and the rest 10% of the traffic will be sent to your test versions. So version which you are going to release it in production. And then with the 10% of traffic, if you can visualize if there are any impact, and then eventually roll out 100% of traffic to the next version. So that's called your canary traffic, canary management. Okay. So these traffic managements are offered in service mesh. So canary, and there is another method of rolling out an application into production, which is AB or blue-green deployment. Blue-green means two version is managed at a time in the cluster, and then at a time 100% of traffic will be only sent to one version. So rest of the application will stand as standby mode. So if there are any problem, 100% of the traffic will be switched to the rollback version, the version 2 or whatever version that you are managing as a standby. So that will be your traffic management in service mesh provides. Okay, so this is provided by other Ingress controllers, but canary, traffic management, the circuit breaking, retry, timeouts, all these are additional features that service mesh offers. And also service mesh does the failure handling, like fault tolerance. You can test your application how much it can tolerate for any outage. So you can inject the fault tolerance and then see how it behaves. So fault tolerance is one of the concept in service mesh, and of course it has observability, right? So you have to monitor each and every problem that's coming into your clusters, right? Like coming into your services and coming into your pods. So those level of observability is possible with service mesh. So how it is done, I'm going to tell you, so don't worry about it. Yeah, I think we had a lot of questions raised. Yeah.
Yeah, can I go ahead?
Yes, please.
So in my, I'm trying to relate whatever you're explaining with my current project. Okay, so we are using, what I learned now is we are using Kong and then as an API gateway, and then traffic as an ingress controller. So this, what I got to know is this combination specifically selected for to make it lightweight, not to complicate. So mainly all these things is purely based on trade-offs and what kind of workload that we have, and whether it is an enterprise grade or mid-scale or those kind of aspects, right? So purely it is based on trade-offs, right?
Yes, and also manageability. So I would say that if you are using a traffic, there is no need of Kong at all. You can just manage traffic to do everything.
But then why they're using Kong? I'm not sure. We do have a Kong. Kong has a, maybe they're using it as an external facing gateway.
Okay. So maybe for some application they might be using these. But if you have Istio, I would say if I have Istio and Nginx Ingress controller, I can just choose one. Okay. Or you can keep these two tools, and then usually even in my previous customers, what they have multiple ingress controllers. Okay, so one is Nginx and one is Istio, for example, I'm saying. Okay, if I have two of these ingress controller, so some of the application who don't need canary, who don't need this advanced traffic mechanism, then they will go for the basic ingress controller. Okay, so if someone needs service mesh capability, and then if they need sidecars, these retries, timeouts, they are managing canary, and they are managing A/B testings, and then they are doing some traffic mirroring. So advanced level of service mesh capability, if they want, then we will recommend them to use Istio. So there are two things. So based on the application need, we advise, as you said. So that's for sure. And then it's not necessary that we should have two of these onto the cluster. It can be managed by single tool. Okay, so why to add a complexity of managing two of them? But if there are application needs, there are simple application, they don't want to go for a Istio or configuration for each and every application, then they can go for the Kong, as you said. Okay, so that is purely. So if you check the configuration of Kong and then configuration of your traffic, just see that there won't be, I think there won't be any mix of this two for a single API.
So sorry to interrupt. We are using GitLab for deployment. So is there these are two separate YAML files, huh?
Yes, Kong will have a separate YAML file, and for Istio you will have a separate YAML file. So basically, in the middleman, what is required is this gateway API. So basically, you need the HTTP route if you are using Kong, but same HTTP route can be used in Istio as well. Okay. So in the middleman, you just need the gateway API, and using gateway API, you can send traffic to either Kong or Istio or your traffic or console. So any traffic will be routed to tools based on this HTTP route config. This HTTP route is provided by gateway API. So gateway API is just it will install few CRDs onto your application to ensure the traffic flow, because Nginx is deprecated, right? So that means its API will also not work. So to replace it, gateway API is the one that is offering the routing. Okay. So, but gateway API will not do your traffic management. Okay. It just provides from some CRDs to create few resources, which is HTTP route, for example. So this HTTP route is a replacement of Nginx. It's Nginx Ingress Controller resource. So we have seen this resource, right? Yesterday we have seen this. This ingress. So basically, this ingress will not be used in terms of gateway API. So all that they will use is gateway file. So in the kind, they will have gateway, but the configuration will be as is. Okay. So that means without ingress controller, we are using gateway API. And then in the ingress class, you will change it to Istio. Okay. Istio, or what do you say? Kong or traffic. So this will be changed. Yeah. traffic, this will be changed. And then instead of this, you will have gateway API. This gateway API, and here there will be a change provided by, I think, gateway networking here. So this will be there. So this is deprecated now that we were talking about, right? So basically it will be replaced by a gateway. So this ingress class is the one that is deciding where your application traffic will be sent. So whether it is on Istio or Kong or traffic. So as you said, so you just go back and explore what the configuration is for the application and see how it is being routed for different ingress controller that's available in your customer environment. So it should be the same, and then still they will send the traffic to the backend service. Okay, these all will be the same. So the only change is here, here, and here. Okay.
And see this path routing, and then this path routing, who actually owns it, right? So meaning, see, DevOps. Okay, sorry for going process related, but this path routing also should the information should come from the developer as well, right? Or the service owners. Meaning, which API route path and which service to service.
So basically, who manages this YAML, right? Who is responsible for doing this?
And from where they are consuming the route path? Who is giving that route?
So, so this entire set of YAML, this ingress YAML, where I have this deployment file, service file, all these has to be provided by your application team, right? So maybe we will create a template for them, and then we will give it to them. So maybe they can configure it in their pipeline, or we configure it in the GitOps way. That's different case, but they have to manage this. So they mean, but they cannot explore all the options, right? But they can just go ahead and then explore what is needed for them, and then they can create their own YAML based on their needs. But most of the times what I have seen, they will do misconfigurations. So what they will do, they will take some sample from internet and then they will deploy their application, and then it will be on you. So you will explore what they have done, and then you will fix it for them once until their application is up and running. And then if they need any features like canary, or if they need timeouts, retries, then you will have to give them the template. So basically it will be on you to manage this ingress. So if they do any misconfiguration, your routing will not work. So it will be 50-50, I would say, responsibility. So if your job is based on their need, you give them the template, and then in the template, they will have to configure what is their backend service. And if they are going for a path-based or host-based, those they can change it. But you should be well aware of it.
Which is like a path-based or host-based? Which is recommended mostly for a small scale, like 50 services product?
If it is a single URL, it will be path-based. If it is multiple URLs, yeah, of course, host-based. And then you'll have, if it is a different host, then you'll have to have different ingress file itself, or different ingress rule. So you will have a host mapping here. So you will have something called as like host, like app.com, something. Yeah. So for example, if it is on a different host, again, I'll have another host like app2.com. So for app2.com /API will reach to API service 2. Okay. Yeah. Like this. So it will be a big configuration, or you can divide it into smaller chunks and then create multiple ingress configuration from the application itself. So for example, this app is managed by application 1. Okay. So what they will have to do, they will have to have deployment file, service file, and ingress file for the application 1. And so we have an application 2, so they will have to have an ingress file, deployment file, and service file. So it's all together clubbed onto the application manifest. So you are not managing this ingress file separately from somewhere else, and you are not applying it from kubectl manually. So basically this has to be with the application team. So you can give them the configuration, but they will have to manage it.
Yeah, this is what I'm seeing in that ingress.yaml. So traffic alpha 1, and then kind is ingress route for a ingress route.yaml. So
Yeah.
Which means they are using traffic ingress and they are, and I'm not able to trace where they have used Kong. Should I
So
check
check
in the deployment?
you have to check it in the Ingress class and see how it is being, how the traffic is being sent to the Kong, and then you can check the Kong logs as well. So whether it has reached any traffic.
Okay,
Okay.
okay,
You
fine.
have
then,
a lower environment, you can do one thing, you can stop the Kong to 0 replicas and your application will be down. Then you know. That's a hard way, but yeah.
Yeah. Okay, yeah, got it. We used to check all those things, but not this setting it to 0 and all thing. But we check the Kong logs as well. But I'm just trying to see where they have deployed, where they have set the config for Kong and all.
Yeah,
Traffic
just
I
take
got it.
it should be from the Ingress class.
Okay.
Okay, and also see if you are not mentioning any Ingress class, there will be a default Ingress class, which is the default Ingress class. If found as a default Ingress class, it will take the traffic reference. Okay.
Okay, thanks. Yeah.
Is namespace Ingress namespace scoped, or like it can reach services in multiple namespace from single Ingress?
Yes, you can create in a single namespace as well, or you can create in the application namespace as well. So I can add a namespace field and then deploy it along with the application. Okay.
So the services should be in same namespace where the Ingress exists.
Doesn't mean it can run in a different namespace as well.
Oh,
Because this Ingress has these cluster roles and all, right? So it should have permission for all the namespaces. So yeah, it should work. So Ingress is a namespace resource. Yes. You'll have to have a namespace binder to it. If not, it will create it in default namespace. So since the Ingress is managed by the application team, you don't need to manage the single Ingress, right? So they can manage their own Ingress YAML in their own namespace. So that should be enough. So what I mean is, it's a namespace code, and wherever the application is there, they can deploy the Ingress in their namespace itself. That is the first approach. And the other approach is you manage a single Ingress for all the applications. Okay, but if you delete your single Ingress, which is there in Nginx Ingress, then your all the traffic will be dropped. Okay, there will be a downtime. So better to manage a different Ingress files for different applications, so that there will not be any problem. Someone misconfigures it, someone deletes it or updates it. Okay. So recommended way is have a separate Ingress. So did that answer your question?
yeah, love, yes.
Okay. Just a minute. I was recollecting where were we. So in why do we use Istio sidecar? Why can't this complete retry logic, load balancing, monitoring, failure handling will be it can also be done at the application level, right? So even the application developer can do all these with some Java codes. So they can additionally do some codings, and all these encryption, everything can be managed from their third manager. Everything can be managed within the application itself. So you don't need to do all these things with the tools, right? So what is the advantage of using a separate class over the application team that they do everything in their Java code itself? So what do you think? So which is preferred? What do you think? Any guesses? So the same thing can be done by your application itself, right? So what is the point of using the service mesh at all in that case, if this can be achieved in that way? So basically, what they will have to do, they will have to do additional code configuration. They'll have to introduce a network logic inside their application, and then with that they can do these retries, fault tolerance, canaries, encryptions, everything they can do it. Okay, but what is the complexity of doing it? So each and every application developer, they will have to rewrite their codes. So the entire application logic, they'll have to rewrite it. So for each and every service, these logic has to be written. So which means they will have to do more work just for this networking stuff. Okay. So for example, if one service A does all these, then again the same effort will be done for service B. Where am I? Yeah. So service A has created their network logic, and then they have done the retry mechanism, certs, everything. They managed it in their application code. So we don't need Istio, right? So I have another team called service 2. So they have to do the same effort again, right? They'll have to do the same thing. But if this team is using Java and this team is using .NET application, then completely different, right? So complete different set of codes has to be rewritten by the developer end, right? So that is a drawback of redoing all the codes for different application for different application languages, right? Supported languages. So they will have to rewrite everything to avoid that work of rewriting the code. So we are introducing a tool called Service Mesh to do all these work for them. So they don't need to change any code. No change in the logics, no change in the application, zero code change. With zero code change, they can make use of all the features that's available, all the advanced features that is available with the service mesh. Okay. So what are the features that we were talking about? Yeah. TLS encryption, retries, load balancing, mirroring, traffic mirroring, traffic management, monitoring, failures handling, circuit breaking, everything they can handle it without changing a single piece of code. All that they will have to do is like this. For example, if in the case of Ingress, you will have a Ingress YAML. In case of Istio also, you will have Istio YAML, Istio related YAML files deployed. So that will take care of all these the encryption for the configuration that we were talking about, right? So features that service mesh offer. So without any code change, this can be done by the tool itself. So reusability. Any different languages, any application, any services, all that they'll have to do is they will have to enable it and use it. That's it. So with that single YAML, it's very easy, right? So you don't need to do a lot of configuration at the application end. Okay. Is that clear? Are you all following? Should I repeat or is it okay?
Yeah. Can you repeat please once?
Okay. So basically this service mesh features, right? So what are the features of service mesh? Can someone recall?
Load balancing, traffic management, fault tolerance. Yeah.
Yes. First is service discovery. Yes. Service discovery. And then encryption, retry logic, load balancing, monitoring, traffic management, failure handling. So all these are features of service mesh. So these are problems in the microservice architecture. How it is solved? It is solved with microservice. It is solved with service mesh feature. So service mesh is offered by different tools. So one such tool that we are seeing today is Istio. Okay, there are other tools like Console, Traffic. They are also providing service mesh capability. Even Cilium also provides service mesh capability. So there are a lot of tools available, but Istio is widely adopted. It's been there for, I think, around 5 years, and then it's widely used. So it's an enterprise scale, and it has been a graduated project in CNCF for a long time. So that's why this Istio is being used. So when it comes to why do we need to use Istio, you can use the basic Ingress controller. It's based on your application need. If they want all these advanced mechanism in their application, then without making any code change, you can just enable all these features by using this YAMLs. So this is for Ingress. So you will have a separate YAML for Istio. So just enable Istio and then make use of all these features available. Okay.
Ma'am, what is service discovery? Can you please explain again?
Yes. So these services are how these services are discovered. So this can talk to this service. This can talk to this service. So all these are by default it can talk. But do we have any security mechanism in between? No, right? So here you will introduce the encryption logic. Encryption or and then you can visualize the traffic flow. And so this is called as service discovery. So that's the use of service discovery.
Okay.
So basically to discover all the services that are running in your cluster. Just imagine like that. Yeah. So it moves away the responsibilities of rewriting the application code. Okay. Just that with the infrastructure layer, all these logic will be handled. Okay. You don't need to write, your application team or your developer don't need to write any difficult logic to handle all these things. So the entire problem with the microservice architecture is taken care using service discovery. Okay, service discovery with service mesh. So all these are handled there. Okay, and by default, this will have an observability. So your observability tools like ELK can watch what happened. If there are any failures at the application layer or at the Istio end, you will have logs to trace it. Okay. Yeah. So detailed logs will be available. So how this is done, that we are going to see now. So far, is it clear at least with the concept? I think someone asked, can I get a response? If not, I can repeat it again as well, or maybe I can recall it in the end of the session. Okay. So how this is basically done? So for now, we have created a Nginx deployment, right? So far. So how many containers were there? So how do you know how many containers are there? How many containers were there? So in the pod YAML, you will see container field, right? So see the number of containers. So this is an array of containers. Your single pod can have 2 containers, 2 or more containers. But if you see here, it has only 1 container. Okay, so this is the status field. So it had only 1 container, right? So here also you will see 1 bar 1 means 1 container. Okay, but to make this service mesh work, you need to introduce an additional container called Istio container. Istio sidecar container they will call. Sidecar means each and every application container will have a small proxy container running along with it to do all these traffic management that we were talking about, right? So these service discoveries. So how this will be discovered? So all the pods will have additional container which is called as Istio container, and that Istio container is the one that talks to your that talks to the Istio master component, and then it does all the traffic routings, and then these the advanced feature that we were talking about, that is managing those features. So if you enable Istio, you will see at least 2 bar 2, which means 1 application container and 1 sidecar container. So sidecar container is the one that will have your application visibility. Okay, so that with that sidecar container only, it is going to do your TLS encryption, MTLS, all these configurations will be done. So we are going to see them in detail, but we'll have a sidecar container. So I just want to mention it at this point in time. So with Istio enablement, you will see 2 bar 2. So additional container. Single application will have 2 containers, one for service discovery and another for your application container. Okay. So that the Istio container is sometimes called as proxy container or sidecar container, or they call it Envoy. So all these are same. Okay. So all the traffic flow will be controlled by that proxy container. Okay. So basically how this Istio works, it basically works by injecting a sidecar proxy into every pod. So this proxy is sometimes called as with different names like Sidecar Proxy or Envoy or Istio containers. So they call it in different way, but all remains the same. Basically, it's a sidecar. Okay. So with this sidecar container, what we will do, we will control the ingress traffic and egress traffic coming to this pod. Okay. So let me go back to this picture. So this is an ingress traffic reaching here. And for this service, this is going to be my egress traffic. So all these traffic is not communicating directly. So how it is communicating? So each and every pod will have two containers. Istio container and another container is your application container. Okay. So like this, you each and every pod will have two containers wherever Istio is enabled. And then this sidecar container, it will talk to Istio master component. Istio master component is called as Istio-D. Okay, let me open the Istio document architecture and then go through from here. Okay. So for every pod, you will have a sidecar container called proxy container, and then this proxy container will be talking to the Istio master component, which is Istio-D. So coming to the architecture of Istio, I think I'm getting a background noise. Somebody mute. Thank you.
And the service A and service B is the pod or like service which we create like cluster IP or the node port or
Let me come back to it. So now we are seeing the Istio architecture. So in the Istio architecture, you have two planes. One is control plane, another one is data plane. So this control plane means you will see Istio-D pod that's managing all your control plane activities. I will tell you what are all the control plane activities in a moment. But this is your Istio master. Consider that as a Istio master. And then you will have so this architecture is a master slave architecture. So master is running in control plane. Okay. So where you will have a separate Istio-D controller. So imagine like yesterday we have seen Ingress controller. So similarly, you will have Istio-D controller. So it is your control plane or master, whatever you can imagine. And then you will have another layer called data plane. So that is where your application pods coming into picture. So here service means it's not the Kubernetes service. Basically, you imagine that as a pod. Okay. Imagine as a microservice. Microservice means a pod, right? So in the pod, you will have two containers. One is your application container. Another one is your sidecar container. So that's what I was talking about, right? So this sidecar container. So why does every pod needs a sidecar container? Because the sidecar container is talking to your master. So you are injecting a sidecar container, right? So Istio-D. So where it sends all the details, it sends to master, Istio-D. So now you have an intelligence. So Istio-D has all the configurations, right? So with that, it can control the traffic however they want. So based on the Ingress based on the Ingress controller configuration that you do for the application, it has all the data, and then using that data, it sends the traffic. So based on which feature they want, it is going to perform the logic behind the scenes. Don't need to do any code change by the application or by you itself. So just need to enable the Istio configuration. That's it. So basically, this service is nothing but pod. Okay, it's not your Kubernetes service. So because in service, you cannot inject anything, right? So in the pod, you can inject another container, which is your sidecar container running along with your application. This sidecar container has ability to talk to Istio master component, And with Istio component only, you will get all the intelligence of doing the traffic mirroring, traffic management, and TLS encryption, TLS termination. So all these is possible using this sidecar container enablement logic. Okay, did that clear?
Can I ask a quick question? So the, Kubernetes also has a control plane and a data plane, on top of which, if we plan to use Istio service mesh, then this also has a separate control plane and data plane, is what you mentioned.
Right. So Kubernetes itself a master control plane, data plane concept, right? Similarly, this tool is also it consider that this has a separate cluster. Like it also has a master and slave component. Master means control plane component. Slave means who is going to do all the jobs. Okay, collecting the data, sending it to somebody else. So all these will be taken care at the data plane. So this is also a master slave component. So don't get confused with the Kubernetes logic. So this is called the Istio architecture. Okay.
And the another name is also an Envoy proxy, or because here is where I really get confused with the names. Okay, I went up to this level and suddenly I got to hear about Envoy proxy. So that is different.
Proxy, no. So they can call it as sidecar container or Envoy proxy or proxy. Yeah, I think I heard only these three names. So they can call it with any names. So why they called with Envoy proxy? This sidecar container has an image which comes from Envoy. So there is something called as Envoy that is only providing the sidecar image. So that's why it is called as Envoy container. Sometimes they call it as Envoy container or sidecar container, sidecar proxy. So Envoy, proxy, sidecar, all same.
Okay, everything is same. Okay, because the Envoy is nothing but it came from them, then that's why it is still referring to the same name.
Yes,
otherwise it is all sidecar only, correct?
Everything is sidecar, proxy, Envoy, all are same.
But okay, in real time, let's say in a banking project, sorry for extending this topic, but in a banking project, let's say for one of the payment scenarios, they had a sidecar container, okay, on a GCP, and they have everything managed by GCP, and also they have a sidecar container. But what purpose it is going to solve? It will add more security, and also it is used for observability and then getting metrics from pod to pod communication. And this is the whole purpose, right? And
that's the whole purpose. And also, if you are doing a canary deployment, if you are doing a A/B testing, blue-green deployment, and if you are doing a live traffic mirroring, which is called traffic mirroring, so 100% of traffic, when you receive on one application, you can do a traffic mirroring, right? So you can. So this Istio has a feature of doing the traffic mirroring to another service, another application that's deployed in your application. So no user is going to interact with that application at all. Just the traffic is mirrored so that you can do your testings in the new application. So similar production traffic is replicated to the dummy service, and then with that you can do testing, like how your new service is going to withstand the live traffic. So all these advanced feature, how it is going to be done. So we need someone to collect all these data, right? So who is going to send me the data? That is my Envoy proxy. But who is having all these data? That's my Istio. Istio has all the and then so it's going to give all the features that's available, and you can make use of it. So yeah.
But I believe this Istio is not going to create any overhead to the service, right?
Basically, I don't think there will be any overhead because this has been used in enterprise scale for a long time. Okay. So it should not create any overhead. If it is creating an overhead, then you have to see your application architecture, and then I think it should be corrected at the application side. So it will introduce a little delay, I would say. It's not same as that of having one container, right? If you are having a traffic mirroring or canary, all these things, then Istio is involved, the sidecar is involved, right? So there will be a minor delay. Okay, latency will be there. So,
Okay.
but that latency should not be visible at your application end.
One last question.
If
So
your
with the
application-
service,
Just a
okay.
minute, I'll complete that. If
Oh,
your
sorry.
application cannot withstand the Istio lag at all, then you can choose to have another ingress controller without having these advanced complexities and advanced features. So just use basic ingress controller and solve the purpose. Just go for a Kong, and then that should solve these delay. But ideally, you should not you should not just to go back between the ingress controller just to fix the application configuration. If it can never withstand such a small lag, then I think your application seems to be more critical and or re-architecturing is required for that application. So until that time, you can switch back to another ingress controller, okay, which does not increase complexity.
Okay. One last question. So let's say with this Istio, if I can do a service discovery, then if I want to create a graph RAG or a kind of a like Neo4j, right, which does graph like nodes. Let's say when service to service communication is
Yeah,
happening.
that's possible. That's possible.
Yeah.
We can see while I'm showing. That's fine.
Yeah. Thank you.
That
Okay.
is there. So basically, someone asked me what is this service discovery, right? So these application. So the service discovery is nothing but your application discovery, your microservice discovery. Microservice discovery means this pod, every pod will be interconnected using Istio. So now your service to service communication, it will not happen directly. My pod will not communicate like this, like my, so I have this pod, right? So I have pod 1 and this pod will not talk to this pod directly. Instead, how it will talk? It will talk to sidecar container. This is my sidecar container. So each and every pod will have a sidecar container. Here also I'll have a sidecar container. So this will have a sidecar container and then it will
At the end of the day, the resources are spawned up from the nodes, right? Even for the sidecar container.
yes.
Okay.
So I have a one pod and then that pod will have a Istio sidecar container and application container. This is another application. Just forget all these. I'm very poor at drawing, but yeah. So now, I have another pod which is also having a sidecar and application container. So these two are two microservices. So how these pod-to-pod communication will happen? Does it going to talk directly? No, right? In between, sidecar will come into picture. And this sidecar goes to Istio, and this sidecar is going to talk to the sidecar of this application. So how will I map it here? So basically, I have to map here. This is this sidecar. Okay. Did this make any sense? Like, so this pod is having a sidecar container and an application container. So if this pod-to-pod communication is needed, then it's not going to be a direct communication. Like usually how it goes from the service and then service talk to another service and reaches this pod. That's it. So without Istio, the communication will be like this. But with Istio, how it is going to happen? Your pod will have a sidecar container and sidecar container will send all the details to Istio, which is your control plane. And then this Istio in turns talks to the sidecar of the pod 2. So this is how the communication will be. So direct communication will be stopped, but the communication between the services will happen through sidecar container. Okay? It made any sense?
Yeah, ma'am,
Yes.
can you just explain, like, please open the diagram.
So just a moment, I'll finish it up.
Okay, cool.
So these proxies, right? So these proxies does not only manage ingress. So it also manages ingress traffic, and then the Istio receives the ingress traffic, and then it communicates to the pod B, which has a sidecar container, and then even the egress traffic will be controlled by your Istio. So not only the ingress traffic, egress can also be controlled. So that is what I wanted to add. Yes, now go ahead.
Yeah, so where the service will exist, like the communication is going through with the Istio D.
Sorry.
Where the service will exist, like cluster IP or the node port or the load balancer, or like if we are using, if the communication happened with the STOD.
Hmm. Yeah,
Like, can you just show me the diagram?
this one.
Last yesterday diagram. You showed me multiple services.
Hmm. Yeah, I'll remap it. Don't worry.
Okay.
Okay. So basically, we'll have a service A, and then service will have a pod A, right? Pod
Yeah.
A, and then we'll have
Container.
sidecar A, then it will have application container. This is my application. Okay. So service will have pod will have two containers, and these sidecar. So this is for service A, right? And I have similar one for service B. Okay, I have for service B. We'll have pod B in sidecar B. These sidecars, they will talk to Istio D. Istio D, which is the control plane, it's the master. This sidecar will also talk to this master. But is this clear? Up
Okay.
to this diagram? Okay.
Okay.
So my service will have a pod, and pod will have sidecar, and these sidecar will talk to each other. Okay. So now, so without sidecar, how it would have been? So you can just call the service directly. Okay. This service will reach here without Istio. So this is without Istio. So this is with Istio. So with Istio, sidecar will be involved in between. So every pod to pod communication. Okay. So actually the pods will not talk to the other pods. So all the communication will come from this service. This is nothing but your K8 service. Okay. So don't get confused.
It's like a load balancer or node port or cluster IP, right?
Yes.
Okay.
So cluster IP, just imagine as cluster IP. Okay.
So Istio D control plane will be there in the each pod, right?
Yes.
It's not like
Just a moment, I will come to that. I think we should start the demo. Then you will understand more. But I was just going through the concept. So now this is your Kubernetes service, which is cluster IP of my application. So how to map it here? Like this. So this is the service, right? This is that service. What is my pod? So this is my pod. So this is my deployment, which is creating a pod. So here, if you give one container, it's just the application container. But if you enable Istio, you will have another container configuration like this. So another configuration will be your Envoy proxy container. So this 2/2 will be there. Okay. So without Istio, how the communication will happen? So this service can directly talk to this service. Okay. There is no middleman. But with Istio, how the communication will happen? It will not happen through this route. Instead, it will happen from sidecar, and then this control plane, it reaches this control plane. If it has to talk to the service B, so it goes through the sidecar only. Okay. So sidecar is the one that is going to communicate between the pods. Yes, tell me.
So can we say, like, if we are using the STOD, we will not use the services? Hello.
Okay. Yeah, I got your question. So I think we should start the lab and then I will explain you more. Okay. I think it's hard to explain in the diagram, but I will show it in here in the lab. Can someone start the lab?
Yeah, sure.
Then we'll go back to the concepts again. Yeah, who is volunteering today?
Yeah, let me share my screen.
So meantime, I will try to explain when we complete the lab. Okay, I'll do something for that. Yeah, you can start the week 5 lab and then proceed where we left off yesterday.
Istio download complete. Istio. I think Istio is not installed in the system.
Yeah, you have to export.
Okay, now it's working. Hello.
Yes.
Yeah, I just hit when hitting this command, so facing some issue.
Okay. Um.
Oh, yeah.
Connection refused. Can you check the pods are up? Can you check the namespace? It should have Istio system. So just wait here. So you will have these pods, right? So Istio D is the master pod and Istio Ingress Gateway for Ingress traffic control and Egress Gateway for outgoing traffic.
It's like a security group, right? Where we can, like, ingress is incoming traffic and egress is the outgoing traffic, right?
Okay, yes. But
Okay.
within the Kubernetes cluster.
Yeah.
Security group means I didn't get what you mean here. So basically this ingress traffic controls, like what is your ingress traffic configuration, everything is managed using this ingress gateway. And then outgoing traffic, if you are doing any outgoing traffics, and if you're restricting any outgoing traffic from your cluster, it is done by your egress gateway. So that is the work of the egress gateway pod here. So all the master activities will be taken care by your Istio D. So basically all your Istio configuration, certificate mapping, and then yeah, so there are different components called Galley and cert maps. All these will be taken care by Istio D behind the scenes. You don't need to do any activity with respect to Istio D configuration. All you have to do is you have to just install it and enable it, and add the application in. You just have to create Istio virtual service and destination rules that we are going to see what are those YAMLs. And with that YAMLs, it will send the traffic to the destination by using Istio. Okay, so yeah, now you have installed Istio. So now your port forward is, can you check the service IP? kubectl get service space Istio system. Yes, Raj.
Ma'am, may you please help me to understand the command 65 kubectl port forward service history?
So port forward is nothing but you are accessing the application directly from your local machine. So you don't need to have any IPs, you don't need to have any DNS configuration at all. So you're just creating a tunnel for your application and you're accessing it in your local machine. So that's the use of port forward. So if you deployed an application, you want to check whether the application is working or not. Yeah, so there are multiple ways to do it. One simple way is to port forward and check.
Okay. Ma'am, may you please break down the command 65?
Which one?
The 65th line command.
Yes,
Port forward. That
port forward. So we are port forwarding the Istio gateway for gateway service. So basically, what we are going to see, let him port forward and see what he's getting.
This is a service, I think.
The service Ingress gateway has an IP assigned. So you have the load balancer also assigned. Can you do the port forward now? Port forward service Istio Ingress gateway, which is right.
MPT server.
Oh, that's fine. So you are not hitting it from the application, right? So
Yeah.
just port forward it and access the 8082 localhost. That's it. Just copy this 127.0.1/8082 and access it in your browser.
Yeah, it shows error, right?
But that's fine. We have not deployed any Istio now. What happened? So forwarding. So did you create a cluster now or?
Okay. Yesterday I have created the cluster.
But that should work. Can you change the port and check once?
Yeah, sure.
Forward port.
Okay, well.
Yeah, let it port forwarding, but that's fine. Let's dig this error later.
Okay.
So your Istio is up, right? So it had three components, which is Istio D, Ingress Gateway, and then your Egress Gateway. So these are the three pods that I have seen there. And then in the service, can you do the kubectl get service? Yeah, Istio system. So basically in the external IP, you are seeing a public IP or private IP. So based on the need, we will assign an IP. So you are seeing one load balancer IP here, right? For Istio gateway, you have one IP assigned. So this is your load balancer IP. So I think someone asked this question. So how it is being mapped, right, from yesterday's session. So let me remap. I'll take the control now for a minute, and then let's debug it. Yeah. This was the flow. So this you understood correctly, right?
Yeah.
So from internet, you are receiving the traffic to the public load balancer. So this public load balancer is the IP that is assigned in the Ingress controller. So at yesterday's session, what we have seen, our Ingress Nginx controller had a one load balancer IP. So with one load balancer IP, we were doing path-based routing, everything yesterday. So is that clear? So that flow is clear, right? So we send the traffic from internet, and then it is received by the load balancer IP, and that is consumed by your Ingress controller, and then with Ingress rules, it sends traffic to your API and front-end service based on whichever path you configure. So this was our yesterday's flow. The same flow, what we are doing, we are just changing the Ingress controller. Instead of Ingress controller, we now change it to Istio Ingress controller. So yesterday we were seeing the Nginx, right? So now today we are seeing the Istio here. So Istio service mesh. So the traffic flow will be replaced here. So here instead of Ingress controller, it will be your Istio service mesh. So the service mesh will send the traffic to your services, API service, front-end service. So based on the traffic routing that you configure in your application. Okay. So this part is replaced now with Istio. Did it clear?
Yes, Lavanya.
Okay. So basically, we are just replacing our Ingress controller to different tool. That's it. We are not changing any logic. So the traffic flow will still be same. So from external world, it has to reach a public IP, and from public IP, it will reach the Istio. Okay. So the public IP that I am talking about is you got a get service namespace Istio Ingress. Sorry, Istio system, right? Istio system part. So you saw one IP. That IP is your load balancer IP for your Istio. And then yesterday you created one more service, right? Nginx service. So for that it assigned one load balancer IP. So that is for your Ingress. So you will have two, for example, if you use two set of Ingress controller in your client, in your customer end, so then two different set of IP will be there. So there will be another logic. So if your service is being hit from internet, so from internet, I'm sending traffic that will be reached by your load balancer IP. So consider public load balancer now, and then from in here, it will reach Ingress controller Nginx, and from here you will have configured your app service. So like your service, right? Service backend will be configured here, and then this will send traffic to pod. So this is with Ingress controller, but we have Istio. So this is also going to be, it's not moving. Okay. So this is another load balancer now and a different IP. And again, this traffic is taken over by Istio service mesh. And then here also you will have routing, which is your service backend, everything will be configured here. This will in turn send traffic to pod. Okay, two different flows. So one separately for Nginx, another one for service mesh. Okay. So why we are choosing one over other? It has its own advantages. So that's why if we need the service mesh capabilities for your application, then you will choose Istio service mesh. So if you don't need such complex configuration for your application, just go with the simplest configuration, just using the Ingress YAML. Okay. So this is where the route is. So if your application, for example, I have an application for internet, it has, I'm having two different applications here. So this is app1.com. So the /API. So this is my one of the application, and here app2.com/API. So if I configure app1 using this load balancer, then what will be picked up? Nginx controller will pick up the traffic and send the traffic to the destination pod. Okay. But if I'm hitting app2, and then if app2 is assigned with a different load balancer IP, which is your, it is your Istio Ingress IP, then it will send traffic to Istio service mesh, and Istio service mesh does the traffic routing your service backend and to the pod. Is this clear? Okay. So maybe I'll repeat it one more time. So from internet, you are sending a request for your application api1.com/API, path-based routing. I'm taking example here. If you send a traffic, if this, so how this is configured? This is configured in DNS. Okay. So consider this IP has some 172.10.10.200. This is my load balancer IP. So here again 172.10.10.201. So this is my another IP. So in DNS server, what I have to configure? Yeah, can someone tell me what will be the configuration? App1.com
will be
pointing to load balancer 1 IP, right? And similarly, your app2.com will be pointing to LB2. In this case, so if you are using Istio service mesh, it will be your under here. So I think Ganesh, you did ask some question about this, right? How this is being configured to pick up which Ingress controller that you are using. So basically, you can just go ahead and check it in the DNS configuration, which IP it is mapped. So if it is a Kong IP, Kong will be your Ingress controller. If it is Istio, then Istio will be your Ingress controller. So it's purely based on the IP that's assigned. So did it answer your question?
Yes. Thanks.
Okay. Priyanshu, you did ask a question, right? So did it replace the service in Kubernetes?
Yeah.
Huh?
Yeah. I asked that.
Yeah, you asked that question. So in this flow, did I replace my Kubernetes service?
No, we are using the service.
We are using the service. Yes, service will still be same. So you cannot call a pod directly. Why? Pod will have a random number. It will keep on changing, and even the IP of the pod will keep on changing based on the pod CIDR that you configure, right? So that is resilient. So that means you cannot call a pod directly. So how it will be called? It will definitely be called by service. Even if I don't say pod to pod communication with via service, then it still means that communication will always happen from service. Okay. So this service we are not replacing, but we are adding an additional layer, which is Istio and this Envoy proxy. We are adding an additional layer for the pod. Okay. So here you will have an additional sidecar proxy. This pod will have sidecar. And again, this pod will have an app container. Okay. So this pod will have a sidecar, but this sidecar can talk to Istio component. But when it has to reach another service, the communication will always come from this Kubernetes service. Okay, we are not replacing Kubernetes service at all. We are adding additional layer to the service. So basically, we are adding an additional sidecar to the pod. So with that sidecar only, your traffic management will happen. So these advanced traffic management will happen. Okay. So we are not replacing the Kubernetes service. We are just adding another sidecar to make all these features work on the application side. That's it. So how it will be done, we will see that in the lab now. Did it clear? Oh,
Yes, sir.
okay. Yeah, Ganesh, did that answer your query?
Yes, yes.
Okay, fine. So just to recall again, I think we did see it multiple times. So pod will have two containers. One is application container. So this is before Istio. So we don't have any Istio. So for in case of Nginx also, this logic will be same. Okay. So I have a pod. Then my pod had only one container, which is application container. So the ingress egress traffic is flown from that single pod. Okay, single container, one pod, one container, 1:1 ratio. For Nginx ingress, this is the concept. Okay, but when it comes to Istio, each and every pod will have application container and sidecar container. So that is named as Envoy proxy. Envoy proxy sidecar all remain the same. So with this sidecar, what we are achieving? We are achieving the ingress and egress traffic flow control. Okay, so that is what we are doing. Yeah. So I think we have seen it already. So we had a control plane master and data plane. Data plane is at the application side, at the pod side. So this data plane means nothing but all your sidecar containers. So these sidecar container, all the sidecar container will talk to Istio master. So with Istio master being the brain of your Istio, so if you enable any feature, this Istio is responsible for making it work. How it will make it work? Because we have control of all the pods. How? With sidecar. So it can do anything with the sidecar. Right? So based on the feature that you enable, we have the sidecar to control the pod's behavior, and with that sidecar, it does everything. What it does, we will see that in the lab now. Okay, I think we have seen most of it already. I'll skip to the next. So before Istio, how the traffic was being forwarded from service A to service B. So it can directly reach two services. Okay, but after Istio, service A can reach to Envoy, and again service B's Envoy will be called. Okay, so it's not so just don't get confused with the word service here. Service in the sense here they are talking about your microservice pod. Okay, so pod to pod communication will not happen directly. How it will always happen? It will always call from service. So service to service communication will be the method of communicating. So sometimes I can say the pod will talk to another pod, which means that via service. Okay, just reiterating the fact, because they will use microservice service all the wordings. Okay, so how we will install the Istio? We'll install through different mechanism. So we have a CLI called Istio CTL. So using Istio CLI tool, you can install the Istio onto your cluster. But is this a recommended way? No, because if you install Istio using this Istio CTL CLI, then nobody is able to track what you installed. If you do any configuration changes, then nobody has a track. There is no YAML configuration for this. So the recommended way of installing Istio is using Helm chart. Okay. So with Helm chart, you can use set parameter to enable or disable some Istio feature. Like we have enabled Ingress gateway by default, and then we also enabled egress gateway by default. If you don't want egress gateway, you can disable it using set command that we have seen in the last class. Okay. Similarly, you can expand for enabling and disabling any Istio features. Okay. And third method is Kubernetes manifest. So you can use kubectl apply and then deploy all the manifest one by one, which is going to be hectic when you do an upgrade. So the recommended method is Helm chart. Use Helm chart to roll out Istio, manage this Helm chart in some Git repository, and then you do the Istio upgrade next time using the same configuration by just changing the version in the Istio chart.yaml. Okay. Able to recollect the Helm session? Okay. Yeah. So I think let me start the lab. Priyanshu, did it work for you, or should I start?
No.
Let me try. You can create a new cluster and try, Priyanshu. I don't know what's the problem.
Sure.
I'm going to replicate it in my machine. Let's see what's happening.
Sure.
So meantime, I want everyone to start the lab and do along with me, and then raise any questions if you have any queries. So I'm going to skip this load balancer service because we have seen it, but we need MetalLB to assign the IP for my load balancer. So that I'm going to do. வாட்ஸ்அப்ல நம்பர் அனுப்பிச்சிருக்கேன், அந்த டிரைவர் கால் பண்ண. நான் பண்ணலமா, நான் கிளாஸ்ல இருக்கேன். நான் அதுக்கு தான் 2-3 தடவை கால் பண்ணேன், எடுக்கல. நான் என்ன பண்ணிட்டோம், அவங்க வரல. அவங்களுக்கு எந்த ஏரியா எந்த ஊருன்னே நான் சொல்லலையே. நான் நம்பர் அனுப்பிச்சிருக்கேன், உங்களுக்கு கால் பண்ணேன். நீ கால் பண்ணி பேசு, நான் கிளாஸ்ல பாதியில இருக்கேன்.
You need to start Docker.
Hello? Yeah, my kind cluster is still spinning up. Did anyone spin up the kind cluster? If you can share. So maybe in the next session, if you have the previous kind cluster, you try to destroy it so that your machine will be faster enough. Okay. Even I'm facing an issue. Let me fix that in some time. So before that, I will take you to some YAML files. So the Istio YAML files. So these are the YAML files which are important when you enable Istio in your application. Okay. So let me explain you what are those YAML files. So basically, these load balancers.
Lavanya, we are not able to see the YAML files.
Okay. Let me share it.
Yeah, now we can.
Okay. So this load until load balancer flow was correct. So was clear, right? Load balancer flow.
Yeah.
Okay. So from load balancer, how internally Istio maps is, so it will have a gateway, which means I think my machine needs a restart, but that's fine. So basically, how it will be done? It will have a ingress gateway. So now you have seen an ingress gateway pod, right? Ingress gateway pod, and then if you have seen the service, it has a load balancer IP. So this is how this load balancer will be mapped to your ingress gateway. Okay, so that's how it will be mapped.
Right?
Hmm?
It's same as gateway API.
So gateway API is different.
Okay.
So this is now we are talking about ingress gateway. Okay.
Okay.
So gateway API, I think I'll clarify it in some time. I think you're raising this gateway API quite often. So I think let's clarify it. Okay. So this is ingress gateway. And then so this gateway will receive all your traffic from app one. Okay, for example, from internet, it will receive app2.com/API. From internet, I'm receiving a traffic to my load balancer. So this is the Istio flow that we just understood here. So this flow, I'm debugging it with Istio. So basically, if you're hitting API, app2.com/API, it will hit a load balancer, which is this 201 load balancer, which is for your Istio gateway. So if you see the service, it will have that IP mapped to it, and then in the application configuration, you will have different YAMLs, right? So what are those YAMLs? So can someone explain what are the YAMLs that are required for deploying any application? So from last class, we have added few more YAMLs. Can someone list what are all those YAMLs?
Ingress.yaml, deployment.yaml, services.
Okay, then
MetalLB install.
okay. So I'm talking about the application side. So last week you have recalled, right? What are all the YAMLs? Like
Role binding, service account, HPA, config map,
Okay.
role binding,
storage class.
yeah, storage class. It's not for specifically for application, but I can list. So if your application needs a separate storage class, then only you will need a storage class. But I'm just listing it now. And the service account. Okay, service account. And what else?
PVP, please.
What?
PVP, please.
PVC, yes. So storage class means you don't need PV. So I'm skipping it. Okay.
Yeah.
What else?
Secrets.
Yes. Then what else? Yeah, I just want to recollect whatever we have gone through. So these are the YAMLs that we saw already. So, but if it is for Ingress Nginx, what file you will have to add? Ingress YAML, right?
Yeah.
Yeah. So, but we are just removing Ingress and then replacing it with Istio files. Okay. So these are the YAML files that are required for us normal application onboarding. Okay. So, but we are just, I'm going to remove this Ingress. Instead of Ingress, we'll have Istio files. So what are the Istio files? So for Istio, we have a file called gateway, comma, virtual service. And there is another thing called as destination rule. So these are the 3 files that are required if you configure Istio in your application. So which means it will add 3 more files here. Gateway, virtual service, plus destination rule. I'll tell you what is the use of it. Okay. So, but understand these 3 are the Istio files that will be added along with your application. So now you can visualize the complexity, right? So as you add on any tool, a new application will be added, a new manifest will be added, okay, to enable it. So all these can be converted as Helm chart, single Helm chart. You don't need to manage 10 or 20 list of files for each and every application. All that you can create an Helm chart for your application team and then provide that Helm chart to them. So they can just modify the values and then do the Helm upgrade when they have to do a new release. So no need to create a lot of files for every time. Okay. So this is your configuration. I will tell you what is this gateway, virtual service and destination rule with an example. Is my screen visible?
Yes.
Okay. So what is mean by gateway? So using the gateway only, it's going to enter your Istio, right? Istio load balancer. So using the gateway only, it is going to enter into your Istio configurations at all. Okay. So you need to add a gateway file. So if you see the gateway YAML, it is similar to your Ingress. So yesterday we have seen Ingress configuration, right? You recall the Ingress, right? So what you will have the gateway configuration, which is Istio Ingress gateway. So here we are choosing where you have to send your traffic to your destination. So it is going to be my Istio Ingress gateway. So with Istio Ingress gateway, I am going to send all the traffics that are coming to this load balancer. So this is what it means. So use Istio's default Ingress gateway. So that is what it means. And then it can send the traffic with HTTP and HTTPS. Okay. So with HTTP, you'll have to configure port 80 and then the name and the protocol. And then with if you are using HTTPS, what you have to do, you have to provide the certificates. HTTPS means we have to provide the TLS cert and key. So how that cert and key is taken? It's taken from a Kubernetes secret. So basically, if you check this secret, it will have a TLS secret and key. So for always for HTTPS, you have to remember that you will have to have a secret and key. So that is what it is being mapped in the TLS section. And then if it receives any traffic from HTTP, then it redirects to HTTPS. Even if you send your traffic for your application, bookinfo.example.com, it will be redirected as HTTPS. Okay, so that redirection is handled. So this is a sample gateway YAML. And then, so this is my sample gateway YAML. So now I have to understand what will come in virtual service. Okay, so this is the next YAML. So don't get confused about how it is being implemented. We will see that in the demo. But for now, just understand this configuration. So in the virtual service also, you will have to map the host of your application. So app2.com is my app. And then what is my gateway name? So here I have created a gateway, Bookinfo gateway. For my application, I've created a gateway called Bookinfo. And then I'm using that gateway. So that gateway will be used for my traffic routing. So this is similar to our path-based routing. For slash, it will send the traffic to this host. So this host is nothing but your service. So I will tell you what it is maybe in some time, but just understand this is similar to your Ingress YAML. So you should have host and then you should have backend services mapped to it. So the Ingress YAML is broken it into two files now. One is gateway file and another one is virtual service file. So in gateway, basically you do only two things, HTTP and HTTP configuration will be kept here, and then the name of the gateway. So these are the two important things that you understand from the gateway YAML. But when it comes to virtual service, this is where your complete routing will take place. So it's basically your routing file. You can consider like that. So all your route configuration, like path-based routing, host-based routing, everything is configured in the virtual service. Okay. So do you understand how a gateway YAML will look like? So this is basically for HTTP and HTTPS configuration. And then this is for the virtual service. Virtual service will be your routing file. Okay. Did it make any sense?
Yes, Lavanya.
Okay. So maybe I'll take a 10 minutes break and then I'll try to fix my lab and then we'll resume it. Okay. Yeah. Thank you. We'll see at 33. 12:33. Yeah, just restarted my machine. So give me a few minutes. I'm fixing. If it is working on any of your machine, you can go ahead and share. Okay, at last, finally, my kind cluster is up and ready. So I need the load balancer. So I'm installing the MetalLB. My screen is visible, right?
Yeah.
Yeah. So if you see the Istio CTL command, so I'm just installing using set command, and there are different profiles that are available. So each and every Istio profile will have its own configuration. So you can have your own profile as well when you do Istio CTL. So there are different profiles like latest, default, and demo profile. But demo profile will be a good start. For example, if you are starting to use Istio, just explore the demo profile, and with demo profile, you can reconfigure all whatever you need. Like if you need any high resource, like you can change the resource configuration and you can enable or disable ingress gateway or egress gateway. And if you want to enable Kiali dashboards, then you can enable Kiali monitoring everything. So all that, so profile is nothing but bare minimal configuration required for your Istio CTL installation. Okay, so that's your profile. I'm using the default demo profiles. Okay, so there are different other profiles called default demo, and I think I also see latest profile. So maybe you can use accordingly, like what configuration you need. But for now, for me, demo should be enough. So that's why I'm using demo profile, because it installs Istio D and then ingress and egress gateway. So both are required for us. So yeah, that's enough. So now it's installing the Istio D component. So Istio D, so this is a single controller. So you will not have Istio D in all application namespaces. So you will find the Istio D only in Istio system namespace. Okay. So in all the namespaces, what you will have, you will have Istio configuration along with the application. If they enable Istio, then your application pod will have additional container. Okay, so that's two different things. One is the Istio control plane itself, and another one is the data plane where your application will have two containers, basically. Yeah. Priyansh, you can restart your machine if you want. Maybe after this session, it should work.
Okay, okay, cool. Thank you.
So now we are installing the Istio, but then do you think all the application need Istio? Do you think all the application need an additional container for them?
Only the container required, right?
Okay. So do you think all namespace need Istio enabled?
Oh, yeah, I think.
Okay, no worries. So if you install Istio, then I will check all my pods, existing pods. Okay. So how many container it should have? It should have 2 containers, right?
Yes.
That's what you mean, right? I'm creating a new deployment, then it should by default have 2 containers. That's what I'm expecting. Let's see. It's still not spinning up. Maybe I think my machine is behaving weird today, I guess.
No, I think namespace issue. Okay.
So I have created a new deployment called Nginx deployment in default namespace. So how many containers you see? You are seeing only one. It did not enable any Istio configuration, any Istio sidecar pod, right? But how we have to enable it? It will not be enabled on all pods by default. You have to enable it. So on which of the deployment you need Istio. You'll have to do this enablement for all the application pods, but that will be cumbersome, right? So all the application pod enabling Istio will be a lot of work. So how it will be done? So basically, when you create any application namespace, so every time when you create an application, you will deploy it in the namespace, right? So in the namespace level, you can enable Istio or disable Istio. So that is how you will do the Istio enablement for the specific pods. So I'm creating a namespace called my namespace, and then I'm enabling Istio. So this is how it will be enabled. So there are 2-3 different ways to enable Istio. So one way is enabling with label. So if you label the namespace, font size is okay, right? Is it visible? Yeah. So how it will be enabled? kubectl label namespace and your namespace name. So this is your label to enable Istio. Istio injection equal to enabled, which means Istio is enabled on that namespace. So if you have an existing namespace, you have to make this disabled or remove this label. Okay. So not disabled, remove this label. So if you remove this label, Istio will not be injected onto your pods. So now if I enable the Istio, and then if I create a deployment in this namespace, Istio will be enabled. So that's how we will deploy Istio. Okay, so I have an Istio YAML. So basically what I have, it has a deployment service, another deployment, another service. So basically /API and /home page service. So yeah. I'm installing these in my namespace. So yes, you are seeing 2 out of 2, right? So which means Istio is enabled in my application pods. So for this pod, if I check the configuration, so how you can check the configuration using OYAML or describe command. So you see here, so far we have seen one container, right? Just a single container. So this is one container and this is sidecar container configuration. So yeah, this is one array and this is another array, which means additional container is added. So what is the what's the use of it? So it is a sidecar container, and then these are all the environment variables required to enable the Istio sidecar. So basically, it will pass some pod name and pod IP, service account name, host IP. So all these are Istio relevant configuration. So these will be passed on to the sidecar container. So these are the required fields that are required. And then if you see here, the image will be Istio proxy container. So why they were referring Envoy sometimes? Because these were coming from Envoy. So that's why it was called a Envoy, sometimes proxy or sidecar. So still if you see, there are Envoy naming convention, it will still be used into these sidecar containers. So that's why these naming conventions are being referred in the industry. Okay. So these are by default, it has some resource limits and then security context, probes that we have seen, and volume mounts, which are required for Istio. So yeah. Yeah. So basically it will have additional container. So that was the intention for me to show this. Okay, so if you see here 2.2, all these application is enabled with Istio. Okay. Is it clear how to enable Istio?
So that means if we are using Istio and Nginx Ingress controller for a single load balancer, we create both in 2 different namespaces, because for this particular namespace, this label will be attached, right?
Yes. Yes. So here, if you see, I did not enable any label in my default namespace, right? So I can enable Istio injection even in my default namespace, right? But I did not enable it. So this pod is not using Istio. So what you can do, you can make use of Nginx Ingress controller, and then you can use this application to route traffic via Ingress controller, which means this flow. Yeah. Yeah. So you can make use of this flow. Okay.
Yeah.
So how to make use of the second flow is by enabling Istio. So how you enable it? You enable it with Istio injection label. Okay. So that means it will add additional containers, and then using the additional container, you can do all these service discovery, load balancing, traffic mirroring, all the features that I was saying about.
So usually we prefer namespace labeling for Istio, right?
Yes, we have to. So there are ways to enable Istio even at the deployment level. For example, if I have I have 2 different applications right now. So one is my app, another one is API app. So now I have enabled Istio injection at the namespace level. So any deployment you do within this namespace, it will have Istio by default enabled. So, but if you want some application within this namespace, if you don't want Istio to be enabled, that also you can do. So how you will do it? In the deployment, you have to disable Istio. So there is a label to disable Istio at the deployment level also. So if you disable that using that label, then you will not see 2 bar 2. So for that deployment alone, Istio will be disabled. Clear?
Okay.
So
Got it.
at the namespace level, you can also do an exclusion always. That's possible. So, but by default, what we will do, you will put everything in the namespace and then enable it for all the namespace and then make use of Istio configuration. That's it, right? So let's move on now. So I'm going to do port forwarding now to access this application. So we have not deployed anything, any Istio configuration at all now. Okay. So we are just we have just deployed Istio and then we enabled Istio. We did not do any Istio configurations right now. So we did not create any gateway YAML. We did not create any virtual service YAML. So with that only this routing will work. So that we are going to see now. So let me open this routing file. So this is the routing file. So what I am doing, same deployment. So deployment 1 with the response API service, deployment 2 with the response coming from web service. 2 services that I'm using for this demo. And then, so 2 deployment and 2 service. So basically, I'm creating only HTTP since I don't have any certificate mapping work, but just understand this. This is only for HTTP. So my gateway works only for HTTP application. Okay. So, and then this is my gateway name. So why this selector is required? So this is the selector that's telling that's telling my gateway to use Istio. Okay. So how will you know this? Which selector you have to use? Kubectl get ports namespace Istio system and then show labels. So for egress gateway, you will have set of labels, right? For ingress gateway, you will have set of labels. So just search as ingress. So this is my ingress gateway, and then all these are labels. So basically, what label is being used there? Istio ingress gateway. So you will have a similar label here. Istio equal to ingress. Right? So based on this only, Istio is getting picked up. Is it clear?
Yes.
So now what we are doing, we are choosing which gateway. So this is the gateway. So how it is being done? It's my ingress gateways label. So labels are used as selectors here. Okay. So now I'm instructing this gateway is using Istio and it's going to take all the host. So basically this is not a production scenario. So ideally it has to be like this app2.com. Okay. So only for app2.com this label will work. So for example, if I have another file for Nginx, okay. So what you will do in such case, what you will do, you will do app1 and then it's not a gateway YAML, it is going to be your ingress. And then here you will see ingress class name as Nginx. Is it clear? So this is how we are choosing. Make sense?
Yes.
For this app, you are using Nginx ingress, and for this for this app 2, we are making use of Istio. So for Istio, we need gateway configuration. This is the gateway configuration. So now we have the gateway configuration. So next thing is you need a virtual service, right? So what is a virtual service? Virtual service is nothing but your route configuration. So in Ingress also you had a routing configuration, right? So for which apps you are going to send the traffic. In my case, it is going to be app2.com, and then which gateway you have to use this gateway. Okay, my gateway, which is there in my namespace. So yeah, it's going to use my gateway. I don't need to pass namespace here because the virtual service is also in the same namespace and gateway is also in the same namespace. Okay, and then we are routing for /API. It will send the traffic to /API service, and I'm having another service, virtual service, to send the traffic to web service. So if I hit web, then I will see the web service response. Okay. So let me fix my YAMLs now. Then I'll deploy it. Let's see what's happening.
So destination rule is not like separate YAML file, right? It just
We are not hitting the destination YAML yet. So just understand the gateway and virtual service. Okay. Let's dig further. I have 4 to 5 set of YAMLs to show a demo. Okay. Give me some time. Did I install routing configuration? Yeah, let me install routing configuration. So now it created 2 deployments, 2 services, 1 gateway, and then 2 virtual service for API service and then for web service. Okay. So if it is going to be a single application, okay. So in my case, I'm using 2 virtual service, okay, but you can still use only 1 virtual service, okay. So just add one more rule for /web. You will have one more rule here added, and then you can use a single virtual service, but 2 different set of application, right? So it's better to use 2 different set of virtual service. So you can have only 1 virtual service for all your application, or you can have multiple virtual service. That's up to you. But yeah, so both has its own advantage and disadvantage. So having a single virtual service, it's hard to manage. Having a multiple virtual service, it's very easy to troubleshoot. If in case of any failure, you have to just look at that virtual service configuration and fix it. Okay. So it both has its own advantage and disadvantage of using. So now I have created 2 services. Let's see the routing. Let me see my forward status. So /API, we are getting a response from API service. /web, we are getting a response from web service. So this is how the routing is been happening. So how it is happening? It's happening using Istio. Okay. So I have 2 services, API service and web service. So both are routing traffic, and how it's routing traffic based on path-based routing. Okay. Yeah. So based on the path that I'm hitting, it's giving me the traffic response from that specific application. Okay. So now we have deployed a simple routing. So now we'll see 2 different versions of service routing. So I have only 1 API server, but 2 different versions. So how to split the traffic? So that we are going to see in next example. So basically, let me come back to the slide. So far, we have seen what's the gateway and what's virtual service. And then I've deployed a simple routing configuration. And then I'll tell you what is destination rule. Okay. So don't get confused. So basically, you don't need a destination rule at all. So just use virtual service. I just said traffic. So traffic flow works without destination rule at all. So just 2 YAML is enough. gateway and virtual service. Okay. So why we need destination rule, that I will tell you. So now routing I have done. So now I'm going to do blue-green deployment. So blue-green deployment means managing 2 versions of application at a time. Okay. In case of any production issue, if you want to roll back, then what will you do? So you will roll back to the previous version. So you'll always manage one active and one passive deployment. That's called blue-green deployment. Okay. So let me delete my Istio routing because I'm going to use the same application. Blue-green. So let's see what's there inside the blue-green deployment. So this is my blue-green deployment. So what's there? Again, I have one deployment which is giving API response from blue and another deployment called green, which is giving me a response API green. So yeah, 2 different versions for the same application. So same label. So maybe 2 different version of application is running in production for your service. Okay. So do deployment and you will have 2 services. So again, gateway file should be there and then virtual service should be there. So virtual service / API means it should send the traffic to green deployment. So this is what I'm telling, subset green. So what is green here? What is green here?
New version of the deployment.
Yes. So basically what is green here? This is blue deployment, right? And this is my green deployment. But subset equal to green. How does it know that's my green deployment? So do I see any subset here? Subset label? No, right? I don't see any subset here. It's just app version and API is mapped here. So what does this mean? So how it sends traffic to my green deployment. So this subset is coming from a separate YAML called destination rule. So destination rule will have this subset. Okay. So that subset, where I am sending traffic to, I'm sending traffic to green. So green means, so in the destination rule, you will have this subset configured. So green means which version of the application has to be served. So version equal to green. Okay. So now I will go back to my deployment and check this version equal to green label. Not calculated. Yeah. Got it. So subset is basically to send traffic to that specific version. So without destination rule also it worked. How it worked? I did not send any subset detail here. So all that I have sent is host equal to web service. Host means calling direct service. So here I will see host equal to web service means direct service link. Okay, I'm calling that service directly and then just passing the port number. So this is without destination rule. But with destination rule, what you will have to configure, destination rule is nothing but to match the labels. So that's what we are doing. So here how you will call, host is API service. Okay. So this is my host. API service is my host. So where it is configured in my destination rule. So for matching host, you are checking for subset green. So what's my subset green says? Subset green says with label version green. So now it will go back to the service and check where is the green label. So go back to the deployment, check this service, and then this has the label, and now the traffic will come from API green. Okay, so that's what we are going to see. So now I've deployed blue green. And then what I have to check, I have to check the traffic of this application. So / API. / API response is coming from green because I have chosen green in my subset. So if I change it to, I think blue, right? Yeah. If I change it to blue, so then the blue pod will be responding, blue label, which is this one. Okay, this application will be responding. So now I have changed my configuration to send the traffic to blue pod. I guess I should see some blue now. So no healthy upstream means it's not sending a response from the pod. Let me check if my pod is up. It is up. I have API green, but I did not have API blue. Why? Still not up. That's why I'm getting a response like that. So now you tell me why it is not responding. How to check? We have to check the describe command. So where it is coming from? It's coming from my namespace and then API blue. It's not able to scale the replicas. Do I have any problem with core DNS? I don't think there is no problem at all. Namespace. The green is there. But ideally, what response I should see? I should see the response from blue pod. So that is where the expectation is. Okay. But you got a picture of what I'm saying, right?
Yes.
So why I'm not getting response? My pod is not up. Maybe my kind cluster is low. But you just understand the concept. That's enough for now. Okay. So we can dig this later. That's fine. Let's move on to the next file, which is
So we can do the blue-green this with the Ingress controller as Nginx Ingress controller as well, right?
yes, it is difficult to manage blue-green there.
Okay, so we'll not have this subset destination rule.
No, this subset destination rule, nothing will be there in your Ingress controller. That's not possible. Okay, so let's move on. So now I'm going to do the canary. So what is canary? Can someone explain? If you know.
Like we send the 50% traffic to the first release, and once the second release will up, then we'll send half of the traffic to the second release.
Yeah, exactly. So I'm deploying a canary rollout now. So let it scale my pods. It should take some time since it has multiple deployments. Let's see what's there in my canary. So as you said correctly, so we are going to send the partial traffic to two different applications, two different versions of the application. Okay, so that is what the intention is. For example, I have a stable application, production application. So which is, I'm calling it as API Blue. That's my stable application. And then I have a canary application. Okay, I'm going to test this new version of my application. Okay, so which is this one, API green. And then I have again 2 service will be there. Another one is what I will have. I have a gateway. So this is my gateway. YAML, again, Ingress is selected here. And just move back to the virtual service. In the virtual service, what you have configured, you have chosen the gateway. And for /API, your destination is API service. And then your subset is blue. How much traffic it has to send? This is important configuration, weight. So using the weight only, it will send the percentage of traffic. So which means 90% of your traffic will be sent to blue subset. And then 10% of the traffic will be sent to green subset. Again, what is subset? So subset is nothing but your version that's configured in the destination route. So which host you are calling? You are calling API service. So in the API service, you will see the version green and blue. So basically blue will be sent 90% of the traffic, and then for green 10% of the traffic, which is your canary release. Okay. So I have deployed the application. Now let's see. Let's up.
Ma'am, can we say weight is the like curl request what we are hitting, right?
Hmm?
Like when we hit some the endpoint, so this is called the weight, right?
Hmm.
Okay.
Yes, we can see that. So I am hitting the traffic for this application. So I'm going to hit my API service. Okay. That is my SPC namespace, Istio system. How is this? Okay, I did not deploy the MetalLB. That's why I'm receiving the error. So 200. So what I'm trying to do, I'm trying to hit this 200, which is my load balancer IP. I think I should hit it inside here. Let's see. So basically, it is hitting 200 times. It's calling this. Okay. And then it is sending the response. All right. So I'm getting a response for 200 request. I'm seeing 176 response from blue pod and 24 from green pod. Okay. So traffic is being split. So this is called your canary deployment. Okay. So now I'm currently hitting the traffic inside my Docker. So that's why even if my service IP was not provisioned, it was working. Okay. But how to anticipate this in real production? So you will see for API blue, just keep refreshing it. You will see random green. Okay. But how do you measure it? It's very hard to measure it, right? So that's why I showed you an example from, using the for loop. Okay. So mostly you are seeing blue response. Okay. Is it clear, Priyanshu? This is what you were asking, right?
Yeah.
So now we are done with the canary. So we have done the blue green. We have done the normal routing. Okay. So I'm deleting the same because I'm reusing the same API application for everything. So now there is an additional concept that we are going to look at. So what we have seen so far, we have seen normal routing without any blue-green. And then we have seen canary rollout. Okay, let's see if we can replicate the traffic mirroring, but it's very hard to replicate the live production traffic because we don't have a live environment at all. But let's see how the configuration will look like. Yeah, so blue-green is nothing but two set of services will be there at a time. 100% of traffic will be sent to one service. Okay, but if they want to roll back to previous version due to some issue, then 100%, so this weight will be made to 0, and here the traffic will be sent to green service. So that is what blue-green deployment. But when it comes to canary, so again, load balancer will be there, Istio Ingress gateway will be there, and then how you will split the traffic in the virtual service, you will configure 80% of traffic to version 1, 20% to version 2, which is your canary release. So we have seen that as well currently. And then, so I'm just explaining the advanced concept that's there. So all that we have to check the configuration and apply it for your application. That's it. So circuit breaking means Istio Ingress Controller, you have a service called UI service. So UI service is the one that is going to hit a lot of load, lot of traffic, right? If there are some problem, then you'll have to break the circuit to stop the cascading effect, right? So if there are already pending queues, that has to be addressed. So new request will be rejected. So you have to break the circuit there. Otherwise, a lot of traffic will pollute your environment, and then you will have cascading effect. Okay. So that is what your circuit breaking is. And then timeout. So for example, if I am sending a traffic to UI service, okay. So for example, if my service is already slow, okay. So it is sending a response after 10 seconds, okay. But if my customer cannot wait forever, right? So you'll have to have a timeout and send some errors. So after 10 seconds or maybe for 15 seconds, you will have to send a timeout, which means your connection will be broken. Your application will send an error. So you'll have to configure timeout. So without timeout, what will happen? It will keep on trying to establish a connection. So maybe if it takes 60 seconds, so what will happen? It will be very, very slow, right? You will not see an error. So you will get the error after 5 minutes or 10 minutes when the application shut down. So it will keep on in browsing state. In the UI, you will see that image will be there, right? The browsing image. So it will keep on in that status without any error message. To avoid that, we'll have to add timeout. Okay. Sometimes application can restart. And then if consider your application needs only one replica and your application is restarted for some reason. Okay, or else randomly your application is giving timeout when connecting to your any of the dependency services like Redis cache or some scenario, just in understand. So you are getting a timeout. Okay, sorry, timeout. Your application is for a fraction of second, your application is down. So in that case, it has to retry. So how many times it can retry? 1 or 2 or 3 times based on your configuration. After 3 retries, if the application is up, then your application will respond. So you can still access the application. But after 3 retries, if your application is still down, your Redis cache connection is broken. So then your application is down, right? So after 3 retries, it will be in failed state. Okay. Got the logic of retry, right?
Yes.
So that's one of the feature. And then you can inject a delay and abort. So for example, if your UI service is giving 500 errors or 400 errors, okay. So what you can do, you can abort that request. So if you are receiving 500 errors, this many number of times, then you can abort that request. So then your load will be, you will not have huge load. So in that case, you can inject a delay. So maybe you can inject a delay. For example, if my application is responding after 10 seconds. So then what I can do, I can inject a delay in such case so that your application will be slow but it will not be polluted. You're purposefully making your application slow to respond to this request. So that's your delay. So for some reason, if you're receiving some error, then you can go ahead and abort the request. Okay. In that case, you will have to configure delay and aborts. So this is coming from your Istio. Okay. And for traffic mirroring, how the traffic will be mirrored? So you have your version 1 application running, but for some reason you want to test whether that application can work on high load scenario. In that case, how you will analyze the traffic? So you will mirror the traffic. Okay, you will mirror the traffic to another version. So user will not see this, but you will just take the traffic and inject to another application, and this application can be debugged further how much traffic it is coming, and then how your application is responding. So for such case, you can make use of traffic mirroring feature. So these are all features that are available in Istio. Yes, Ganesh.
One question. So just trying to understand, is there any way, is there any relation of timeout that we set in the application deployments or in the config files is related to anywhere that you mentioned about this delay and the previous slide, right?
Yes.
Is there any correlation between that?
Yes, yes. I'll show you the example. So let's finish it off. I think we are already delayed, but it's okay, right? Can we continue it or should we resume it in the next session? Can we close it today?
If you ask me, yes, too much to go through. Yes.
Okay. Yeah. If someone wants to resume it next week, just let me know. So yeah, this we can ignore for now. I think let's go back to our YAMLs to understand more on timeouts and retries. So where were we? So I'm going to delete my canary now, and then let's see if we can do something for the timeouts. Okay, let it spin. Let's see what is there in the timeout. So basically, I again have two different deployments. One is for API green, another one is for, yeah, just I think for slowness, it is not required to have a canary or full version of deployment. We can demo it with single version. So I have this deployment, and then I have a service, I have a gateway, destination rule. So where this timeout will be configured, it will be configured in the virtual service. Okay, so I'm giving a 2-second timeout. So it will wait for 2 seconds. If the application is slow, then your application will send an error. Okay, so this is how the configuration will look like, but it's hard to visualize it here with 2 seconds. It's not a production environment, but this is how the configuration will look like, and then retry also. So I have again a deployment service, gateway file, virtual service. So these timeout and retries are configured where it will be configured inside your virtual service. Okay. So now I'm combining the timeout and retry. Okay. So here is the timeout. So 2-second delay I am giving for every calls. Okay. So for every route that it is reaching this API service, I'm giving a 2-second time delay. And then if you see for how long it has to retry, again, this setting will also go in virtual service. So how many times it will retry? It will retry for 3 times, and then per retry, 2 seconds it will wait. So 3 into 2, 6 seconds it will wait. Okay. And then for what it will retry on? It will retry on any gateway error or connection failure or 500 error or refused connection error. So these are the different types of error it will retry on. So these errors you can configure. For example, if you know what is the error that you will receive if there are any dependency failures like Redis cache connection failure, just check on that event and then add it here. So for such event, it will do a retry. after few seconds. Okay, so this is how we will configure timeout and retries based on the errors. Okay, but I don't think so. We'll replicate it. Let's see how much we can do for this. Out and retry. But 2-second response is hard, but you will see a delay in getting a response from this page. Okay, so since it is an Nginx application, it's not going to have any load. I'm not also doing any load generator now. So, but in the real time, what will happen? We are adding a delay of 2 seconds. So after 2 seconds only, I'll get a response. And then if there are any problems, after 6 seconds, it will be timed out. Okay, so 6 seconds, it will wait. So it's not going to terminate immediately. So without retry, what will happen if there is a failure? Then it will immediately fail. So with retry, it will retry the failure, retry on 3 or 5 failure configuration, and then it will reach the application if the application is up. Okay. Got the concept with timeout retries? So these are all the advanced concept that's there with Istio. So we won't be able to cover all the scenarios, but these are just available and then mostly used. So another thing is, I was telling about traffic encryption, right? So let me make it big and then let's see what's traffic encryption. So by default, the pod-to-pod traffic is unencrypted, even with Istio enablement. So how to enable the traffic encryption? You have to enable it manually. So with Istio installation, it's not going to inject the Istio by default. So with Istio injection, it's not going to enable any feature by default. All you have to do is you have to enable each and every feature. So now we have enabled Istio injection. The next thing we have to do is encryption enablement. How to enable the encryption? So like this, you have to enable. So you have a configuration called the peer authentication. So if this YAML, you will have to add it along with your deployment file. So with this YAML, in the MTLS mode, it means it is going to, by default, encrypt the traffic between these two services. Okay. So here, MTLS means it's going to encrypt the traffic between these two services. Services means pods. Don't get confused here. So each and every pod will have 2 containers, right? So these 2 containers, how they will send the traffic? So it will be encrypted mode. Okay, clear, right? What's encryption here? So we'll have to enable it. Yes, Pulu?
Yeah, it's clear.
Okay. So another advantage of using Istio is authorization. So you can enable authentication authorization within your application service. So how you will enable it? So there is one thing called network policy that is going to allow or deny traffic between 2 different namespaces, right? So that's one way of doing it. Another way of doing it is with Istio. So with Istio, what you can do? So in the namespace, in the foo namespace, you are creating an authorization policy for which application? For HTTP bin application. So what it will allow? It will allow the incoming traffic from this service account from this namespace. So basically, you are from namespace dev, you are allowing the traffic to namespace foo, but only for the application HTTP bin. Okay, and then this is for ingress and 2 for egress. So it will send the traffic, the get call will be sent. Okay, so this is for application level restriction, authorization policy for application level, but just by default, people will use this namespace level namespace level policy. So authorization policy in the foo namespace, HTTP bin is the application where this authorization policy is going to work. So on the application HTTP bin in the namespace foo, it is going to deny the traffic from other namespaces, not namespaces foo means it will deny all the traffic except from foo namespace. So means dev namespace will be denied. Did you understand the concept? So you can deny the traffic between these, any of the server workloads, any of the pods by setting the authorization policy. So you have an advanced capability, like you can only send get traffic or post traffic. So that type of traffic authorization is possible with Istio. Yes, Priyanshu.
No. Thank you.
Yeah. Okay. So far what we have seen ingress traffic, right? So there is another thing called egress traffic. So for can someone answer me? Ingress and egress gateway are same or different?
Different.
Yes, because ingress gateway will handle incoming traffic, inbound traffic. So far we have seen incoming traffic. So in this picture, what we have seen from the internet, we are receiving the traffic. But did we talk about any traffic that's going out of the cluster? No, right? So this is all incoming. So from Kubernetes cluster, there is something called as traffic which is leaving the cluster as well, right? So outgoing traffic will be managed by egress gateway with Istio. Okay. And then with this, your egress will be allowed or blocked. So for example, I have 10 applications. Okay. 10 different application is reaching outside world, google.com, maps.com for their application. So do you think that you can allow all the traffic? Or some restricted website also if they're trying to reach from their application? Do you think we have to allow all of them? No,
Yeah.
right?
No.
So we'll have to have a restriction for such access. So how you will do it? So you will do it with this egress traffic control. So how you will do it? So you will enable an egress gateway. So a separate IP will be mapped. So again, this is going to be your in your service. If you enable this, it will have a separate IP. So if you enable this egress gateway, so how it will enable? It is again based on egress gateway. So that we have seen the label map, right? So to ingress gateway, similarly, you'll have to have egress gateway configuration. So for HTTP and HTTPS, so this is how a gateway configuration will look like. So this will be same, it will exactly look same for ingress and egress, both of them. But what will vary for egress? For egress, you have to have this configuration, service entry. So for ingress, you need gateway, virtual service, destination rule. Okay. But for egress, you need service entry. Service entry means what and all host it can reach the external world. For example, if I allow wildcard.google.com, all the endpoints are allowed to reach from your cluster. Okay. So that's how you will reach the external endpoints. And then, for example, you can add, this is a continuation of this. So you can add specific URLs like the maps.com, and then it will reach, so using the DNS server, it will reach the external world. So this is a DNS routing. So basically it will reach the google.com using the DNS mechanism. Yes. Yes, Ganesh.
Okay, so egress traffic, right? So this is on allowing egress traffic means the traffic that is in outgoing or incoming. Sorry,
incoming. Ingress means incoming. Egress means outgoing. Okay. So if you see here, so far we are seeing this, right? So what is this traffic? It's actually coming from outside world to your cluster. to
Which
your
is?
application, which is ingress,
Mm.
inbound traffic.
Yes, yes.
Okay.
Yes.
So from pod here it goes to egress, like external world. External world, that's going to be your egress traffic. So we are talking about this egress traffic here. So how this will be done? So for this, managing this, you will have an egress gateway. Egress gateway in Istio. And for this, how do you control it? Using a file called YAML called service entry. And in the service entry, you will mention the endpoint, which can be reached. For example, google.com. So if you deny all the other endpoints and then only add service entry, then if you try to reach any other apps that's available externally, do you think that will be reachable? No, right? So if you deny any egress traffic, then all your external communication will be blocked until and unless you enable it with the service entry. So basically in the service entry, it will look like, yeah, for some 40, 50 URLs you will add, and then you will manage with a single entry or with multiple service entry for each and every application. For example, I have a namespace, and that namespace has an application API, and it's trying to reach maps.com for some navigation purpose. Then you will add map. You will only allow maps.com application, and then that application will only reach maps.com. Other URLs will be blocked. So that's how you will configure the egress traffic flow.
Okay. Last question. Let's say I'm doing a recharge, okay, in Airtel, and that Airtel is going to communicate to a third party, okay, and then Airtel is my service, okay, meaning let's say I'm working in Airtel and I'm using that service, and it is making a third party call to a different system, and the third party call is going to give callback action again to our to the Airtel system, right? So which means the traffic is going to be incoming to the service to complete a transaction.
Yes. So
Right. So that will be called as inbound to my service.
Yes. So it's again coming from internet, right?
Yeah, third party, yes.
So basically, if the application is hosted outside your cluster, that's considered as external traffic for your cluster, right? So with service entry, you will allow that endpoint.
Okay. Actually, my question was supposed to be on the timeout side. Okay. So when the service is going to be communicating to a third party system, and then this ingress egress traffic comes into picture, and again the timeout will also be an important topic, right?
Yes. So timeout, if you don't set a timeout, it will have a default mechanism in the deployment. Okay. So that timeout will take control. So it's not so you are not adding a delay, or you're not adding a retry, you're not adding a timeout, means it's by default behavior of your application, what it can do. So up to that time it will wait. So you'll have to configure these additionally for your application based on how long it is going to take to respond.
How enterprise teams handle both the timeouts at all components? It's a pain point in any company that I've worked. Okay, so from application timeouts to the this traffic timeouts that you set on the infra layer, not everything is aligned, and things go haywire, right? Is there any way that we can architect or solutionize in such a way that these timeout issues are in sync based on the business requirement? Is there any principle or structure is being followed in the industry?
So basically what they will do, they will not introduce a timeout, delay, aborts and all at the first call. Okay. So it's based on your application behavior. These values, this 2 seconds, 5 seconds, 10 seconds will evolve. So start with nothing, I would say. Okay. First, you just deploy your application. with just enabling Istio. And then eventually you check if you need a more, if you need a timeout set for your application, then enable only timeout, not a retry. So there is nothing in combination. So there is no hard rule that you have to use timeout, you have to use a retry, you have to use abort, you have to use delay. There is nothing like that. So then you introduce your timeouts and see how well your application is responding. If you really need a retry, and then you introduce a retry. So then you will add more and more configuration to make your application respond better. So it's not only, so the application itself, so we cannot do much with the Istio itself. So it's the application behavior that has to be eventually changed. So you cannot do much. Yeah, if your application is slow, what you will do? You will not do much, right? Adding a delay and timeout is not a solution. So eventually it is going to be fixed in the application end. So we are just making the problem better. So we are not solving any problem here. So your application, ideally your application should respond better. So maybe what you can do, you can improve the, what max from the infra team they can do. Increase the resource, CPU memory, and then increase the liveliness probe. And then you can introduce these timeouts and all these best possible configuration. But ideally your application should respond properly. Then you cannot keep on refining these values, right? It's not going to help. So it has to be hand in hand with both the teams. So we are just helping, we are just delaying the problem. That's it, I would say. Not addressing the problem. We cannot address the problem with Istio configuration at all. Make use of it, just that's it. With Kubernetes. Yeah.
Okay.
Okay. Okay. So Ingress.
Lavanya, I'm having a doubt.
Yes.
So even though if we use the service entry object to allow the outbound traffic, so what if we don't have NACL, NAT gateway enabled at the VPC level?
So you don't have Istio now. Okay. So what you have for your cluster? So either you will have a load balancer, right? Load balancer to send the traffic outside world. That is by default. If not, NAT gateway. So two ways, right?
Yeah.
So without Istio, your traffic will definitely be routed through load balancer or NAT gateway, right?
Yeah.
But what we are doing now, so we are not intercepting anything with load balancer or anything with NAT gateway. So it's outside your cluster. So what we are doing within your application, what you can restrict within the namespace. So just imagine that the big picture. So we are not touching the NAT gateway. So you can do the deny at the NAT gateway level also. But we are not doing that. So basically what we are doing this restriction inside the namespace level itself. So inside the namespace level, I am restricting my egress traffic. My application itself cannot reach any google.com or maps.com. So I'm restricting within the application, within the cluster, within the namespace. Okay. So there is also, I get your point. So we can do the restriction without Istio also. How it can be done? Having a firewall. Outside the cluster, you can add a firewall to your NAT gateway and then www.google.com deny. Means your traffic will be denied. Though your Istio sends egress traffic outside your cluster, your NAT gateway can restrict. Okay. Multiple ways possible. But now we are addressing with Istio within the namespace, you can deny the traffic.
Okay, like traffic from sending our pod to another pod, like we can. Okay. Yeah.
Sorry, can you repeat, Swarna?
I mean, blocking traffic or enabling traffic. Do we use egress traffic for that? I mean, service entry object or out. I mean, if we want to download some kind of image, a public image, will this help? Service entry help in that case?
So basically, the image download That's not the thing that we are doing here. So basically, image download will be done. For example, if I deploy a new application, okay. So it is trying to pull a Docker image.
Yeah, we in an ideal scenario, we might be having some ECR or container registry in Azure, but sometimes, let's say we have some Falcon driver, which runs as a daemon set on all the nodes and downloads an image, some drivers. It downloads some drivers whenever the container runs.
So do you think Istio will come into picture in node readiness?
No, at node level, no. Yeah.
No, right? So it comes at wherever you enabled.
Yeah.
Right? It's
Yeah.
not denying all traffic across all cluster. It's denying traffic only at the Istio injection enabled namespace. Okay. Only for the pod where you enabled egress gateway, and then where you deployed this YAML, egress YAML, for which service you deployed the service entry. For that service only it is going to work. So for node level communication, it's not going to stop anything. Okay, if Istio can stop your node spinning up a node, then it will be a big problem, right? So it will be your single point of failure in such case if it can block egress completely. So basically, we are blocking the egress within the namespace only.
Got it.
But within the namespace, if your application is trying to contact some github.com, okay, but you have restricted egress traffic, then it will not work. So then you will have to add a service entry for www.github.com, your company name.
Got it. Got it.
So within your application, I'm talking about, not at the node level, not at the outside cluster level. Clear, right?
Yeah, clear.
Okay. So we can do the observability. We can monitor all these problems with Kiali. I'll tell you what Kiali is. Let's see if we can spin up Kiali with Istio, and I will tell you what we can do with Kiali. And you can integrate monitoring tools to visualize any problems. If there are any failures, timeouts, all these can be visualized in the logs. Okay, logs and matrices. That's possible. So again, a recap, all these features that we have seen it already. I think that's it for today. So let me check what is left in the lab. So we have seen what's timeout and retry configuration, but it's hard to replicate it here with less time delay. So that's why I'm not doing this timeout and retry. Maybe you can try for some application. There would be some application to send a delayed traffic for your deployment. You can go ahead and try it. So now what I can do, I was telling about this Kiali, right? I'm going to deploy this Kiali and see if it deployed Kiali in my Istio system. So Kiali is a troubleshooting tool. So if there are any misconfiguration, then my Kiali will tell, so this configuration is misconfigured. So you have to correct it. So it's very helpful for debugging purpose. Okay. So I've deployed all the configuration. I am sure that there will be some misconfiguration because 2 or 3 services will be sharing the same service configuration. Let's see what my Kiali says. I'm going to put forward the Kiali. So it's 20,001 port. It's still not up. So what I'm expecting, this Kiali dashboard should show some problem. Awesome. So my cluster is stopped now, I guess. Let's see if it pins up in some time. But I think someone has asked service graphs, right? Which service communicates to which service? So all these service to service communication, you can visualize it in Kiali. So maybe what we will do, we will before starting the next session, I will give fix my lab, and then I will show you how Kiali looks and what service graph that you can see, and also you can see if there are any misconfiguration. It should give you some details, or you can go ahead and do this lab yourself. So visualize Kiali and see if it is working for you. So you should see some misconfiguration. So you purposefully do any misconfiguration, and then Kiali will tell you, hey boss, this configuration is incorrect, you have to correct it. Okay.
So ma'am, what's the difference between the Selenium, Hubble and the Kiali? Like, what shows the architecture of the services, how the traffic is flowing?
So you tell me. So
I
you know it. Yes, Priyanshu. So Selenium is having a UI called Hubble, right?
Yeah.
So it is for Selenium network debugging. It's for Selenium observability. Okay, that's Hubble, right?
Only for the specific Selenium. Okay.
It's for CNI, Selenium CNI.
Okay.
But Kiali is for specifically for Istio incorrect configuration. So
Okay.
Istio debugging, Istio routing, Istio service map visualization. So it's specifically only for Istio. So Selenium has Hubble only for Selenium observability.
Okay.
Okay. So Hubble told me what it told me. So if there are any network policy denying traffic between these two different identities, these two workloads, then it showed me dropped, right? It showed me forwarded. So green tick, red tick, right? So that type of visualization at the pod-to-pod communication, whether traffic is allowed or denied. So that type of details you can see in Selenium Hubble. But what you will see it in Kiali misconfiguration, Kiali, and then Istio service graphs. All these details you will see it in Kiali. Okay.
Okay, got it. And one more question, ma'am. As you are while displaying your PowerPoint presentation, so there is a circuit breaker, right? So what is that? Like, if queue is failed, so then it will help with this. So we can use the MS queues like message queue, and also, like, I am not clear with this topic. That's why.
So service breaker, why it is mainly used? It's mainly for failure protection mechanism. So if, as you said, if you have any DB that is failing, so it will have a cascading effect, right? So other services will also fail, right?
Yeah.
So other dependency services, if you see it in the service graph, I have 10 service talking to 10 different services, and it's very hard to imagine what service communicates to what. So if you introduce a service breaker, circuit breaker mechanism there, then failed services will completely stop sending or accepting request. So which means the cascading effect, the failure will be for other services will be stopped. Okay. So for example, I have service A and I am sending a traffic to service B, but my service B is down. Then my service A will keep on retrying, and then it will overload with the system, and then system will crash, right? So in that case, if you have a circuit breaker enabled, even if the service B is down, service A will still work. It will not overload, and then it will not do any crashing. So any failure detected, it will stop sending request and the system will stay stable. That's the concept of circuit breaker.
Yeah. So is it similar with the like RabbitMQ or the message queues which are available in the market? So it is a similar functionality.
So real world, you can say like you have an app calling a payment service. Your payment service is down. Circuit breaker will stop further calls to that service, and then it returns a callback, and then it prevents the cascading failure. So basically, the dependent service, so it's not basically it's not for the RabbitMQ. So it's for two different services that's trying to communicate, API and web service, these two services. So, but your web service, sorry, your DB service, for example, I have a third service called DB service that's trying to connect to your DB or some cache. So then if your DB service itself is down, so then this picture will come into case, like your DB service will be down, right? If your RabbitMQ is down. Sorry, RabbitMQ for cache, right? So cache service is down. So cache -service is down when your cache RabbitMQ is down. So this service is down. And then if this service is down, any dependent services, my DB is trying to connect to this cache service. So then my DB will still keep on retrying, and then it will create a load, and then it will create a crashing. So to address this problem, you will introduce a circuit breaker at the DB port. So not at the RabbitMQ level. RabbitMQ, your application is trying to connect to a RabbitMQ endpoint. That's not the case. So now we are talking about Kubernetes services, right?
Yeah, internally we are talking about. Yeah, got it. Yeah.
Clear, right?
Yeah, clear. Thank you.
So basically within the Kubernetes service, so within the Kubernetes namespace, we are restricting all these at the application level itself. Okay, not at the connectivity levels. So for example, my single service can connect to different APIs. It can connect to cache endpoint. It can connect to different DBs. So all these it can make a connection. So this is not what I am concerned about. My DB, my cache service itself is down. Then how to prevent the cascading failure? That's your circuit breaker will come into picture to address that problem. Okay.
Okay.
I think we have taken too much time today.
Yeah.
I'm sorry for that. It was very hard to explain it in our time. Yeah. Thank you, team. I think you are very patient in understanding the concept. Yeah. I'll give you some lab assignment to explore these topics. Let's see. We'll have a follow-up session, maybe 15 minutes next week, and then fix this Kiali and see from there, and then we'll start. So the next week class is on Argo CD, GitOps.
Okay.
See you then.
Yeah.
Have a good weekend, guys. Bye.
Bye.
Thanks, Lavanya.